Hey, this is Mr. Hanson. I wanted to continue my last video on uh, finding or completing the square. This time it's going to be just a little bit more complicated, and then we'll do a real world problem. You might notice this time we have 2x squared plus 8x minus 6, and this 2 in front of the x squared, there's a coefficient of 2 instead of 1, so that makes it just a little bit different. There's just a little bit more to it, so let's go ahead and jump into this. First thing I want to do is factor the 2 out of this whole right side. So I've got 2 parentheses x squared plus 4x, and then I'm going to put minus 3 way over here like that. And you'll see why in a minute. So just make sure that in your mind that you can see that the first expression and the second expression are equivalent. And we're just kind of factoring out a 2. That gives me the coefficient of 1x squared there, which is what I need to complete the square. So next step, we are going to complete the square. What we need is a blank right here, and I'm going to put an extra set of parentheses right in there. We need a blank right there, and you might remember we half this middle term, so we half 4 and then square it, so half of 4 is 2 and 2 squared is 4. Something like that. Now, if we add 4 to this expression here, we probably need to subtract 4 too to keep it balanced. That's kind of what's happening here. Is this is an opposite pair, so it doesn't change the value of the expression. Kind of a little trick there. Okay, so let's take it to the next step. 2, and now this is x squared plus 4x plus 4. That's the same thing as x plus 2 squared. And if you needed to kind of just verify that to yourself, you could do the FOIL method on that, and you get x squared plus 4x plus 4. And then we have and this is still in the entire thing's in parentheses. We're going to end up multiplying by 2 when we're done here. So minus 4 and minus 3 more, that's going to be minus 7, like that. Okay, next step, f of x equals 2. So we still have a stretch of 2, kind of a narrow parabola is what that provides us, because x is going to increase, whatever x's increases is going to be doubled, and so it's kind of a narrow parabola. Okay, so we've got 2 times x plus 2 squared, and then 2 times negative 7 is minus 14. And there we have it. This would be our, if you were to graph this function and graph that function, they'd be the same exact function. Or if you were to put some numbers in for either function, they'd work out the same. Let's just kind of verify that. Let's put f of 2 in. Negative 2, just to make it easy. So up here, negative 2 squared is 4 times 2, that's 8. And negative 2 times 8 is negative 16, so we got negative 16 plus 8, that's negative 8, and minus 6 is negative 14. Now let's plug in negative 2 right there. Negative 2 plus 2, that's just 0. 0 squared is 0 times 2 is 0, and we also get negative 14 out. So that's one input. You plug it in, you get the same output out. If you plug multiple inputs in, you get the same outputs out. And I guess one big question is, why are we doing this in the first place? That's kind of important. Why would we get something into vertex form? It's because it gives us a maximum or a minimum. So let's just kind of graph this out. I'm going to go something like this. And we are at negative 1, 2 for x, and then negative 14. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, something like that for y. And it's going to be U-shaped because it's a plus 2. So we're going to go over 1, up 2, and back 1, up 2. And you might remember the stretch rules here. When we have a stretch of 2, instead of going over 1, up 1, we go over 1, up 2. Now over 2, up 8 instead of 4. So 2, 4, 6, 8, somewhere up here. And something like that. And you have something like this. If you were to graph this on a graphing calculator or GeoGebra, using either of these two forms of the equation of the function, you'd get the same sort of thing there. All right, so we know we have a minimum right there at -2, -14. Might be important if we had some kind of word problem. Speaking of word problems, let's move to the next one. This is my word problem. It says that we have three things going on. We are starting at 144 feet in the air, like 144 right there. So this is height in feet, and this is time in seconds. And we are shooting something upward at a velocity of 80 feet per second. So it's kind of going in an upward direction. At the same time, gravity is pulling it down at 16 feet per second squared. This should look fairly familiar to you from the last unit. And so let's go ahead and I guess my big question, I'm going to kind of sketch this. We know it's going to go kind of up like this and then come back down. And what I really want to know is this point right there, because that would tell me, it would tell me the maximum height, and it would also tell me how many seconds it took to reach the maximum height. So that's what we're shooting for. Let's see if we can do this. I'm going to start kind of like I started the last one. I'm just going to factor out a -16, and then we have x squared minus, sorry, this is not a plus, it's a minus, 5x plus, or minus again, sorry. Some of these little mistakes I make can be costly if you don't catch them. Minus, I want to say 144 divided by 16, I'm going to plug it in here. 9. Okay. So there we have it. I'm going to see if I can maybe rewrite this a little bit. -16 times x squared minus 5x, and then big space minus 9. This is all in parentheses because we factored out a -16. Now let's half the 5. That's 2.5. And then we have to square. That's going to be 6.25. So plus 6.25 and minus 6.25. That little trick there that really doesn't change the value of that expression. And now we kind of take a look at just this piece right here for a minute. And this is a perfect square trinomial, so we're going to break it down to a perfect square of two binomials. So x minus 2.5 squared. And believe it or not, we already know what the number of seconds is going to be when you're at your maximum height. It's going to be 2.5. And then minus 6.25 minus 9 is going to be minus 15.25. And I put an equal bar there. I need to put a minus 15.25. Okay. Now we are almost there. We just need to multiply in. We factored out the -16. Now we're going to multiply it back in to kind of meet our need here. So -16 times x minus 2.5 squared, and 16 times 15.25 is 244. So plus 244. You have, of course, a negative here times a negative there is a positive. And there we have it. This is our function in vertex form. If you plug this in a calculator or that in a calculator, it'd give you the same exact thing. But just looking at this, we've got a 2.5 comma 244 as our maximum point, which is kind of nice. 2.5 comma 244. So in other words, several things happening here. At 2.5 seconds, we stop increasing and we are going to start decreasing. At 2.5 seconds, we've reached our maximum height. And at 2.5 seconds, that maximum height is 244 feet in the air. So I hope this made some sense to you. Completing the square is a kind of a very nice way to change an equation in standard form to a vertex form, or a function in standard form, and move it to vertex form. And it's also a very nice way to find a maximum or minimum. Now, is there anything wrong with using a calculator and just plugging it in standard form and then finding that point using the calculator. No, there really isn't anything wrong with that. That's fine if you do it that way, if that's all you're looking for. But this kind of gives you an alternative method that you can use. Hope this is helpful to you. And the big idea here was just completing the square when that coefficient in front of x squared is not 1, when it's something besides 1. Take care and have a good day. This is Mr. Hanson signing out.